Here we're looking at circle problems dealing with the Pythagorean theorem. So, first theorem that we're looking at is the angles within a semicircle. Okay, so a semicircle is half the circle. So anytime we have a semicircle, no matter where we place C at in that circle, it will force a right angle within our circle. Okay. So let's look at an example that we can use that to solve a problem. Okay, a circle has a diameter of 13 centimeters. Z is a point on the circle such that XC is 5 centimeters. Okay, find the length of YZ. Well, since I know that it's forced, and this is a right triangle, since Z is 90 degrees, okay, I can use my Pythagorean theorem. I'm going to redraw my triangle. Okay, my hypotenuse is 13, my short side is 5, my unknown is x. So I have x squared plus 5 squared is equal to 13 squared. Okay, so I have x squared plus 25 equals 169. Okay, subtract 25 from both sides, subtract 25 from both sides, and I have 144 is equal to x squared. Taking the square root, I have x is equal to the square root of 144, which is equal to 12. Okay. So, next example here. Okay. Talking about a line drawn from the center of a circle at a right angle to a chord bisects the chord. Okay. So, this is what we call a chord from one side of the circle to the other, not including, it does not go through the center. So if we draw a radius to the end of the chord, okay, and from the center, we will force a right triangle there. And these two triangles end up being similar. Triangles 1, triangle 2. So let's see how we can use that to solve a problem. Okay, a circle with a radius 8 centimeters has a chord length of 10. Okay, find the shortest distance from the center of the circle to the chord. Okay, so the shortest distance is going to be our perpendicular distance to our chord here, and our chord goes from A to B. Okay, so we want to find x here, the shortest distance. Okay, so since that chord length is 10 and this is bisected here, we know that this triangle here is 5. Okay, our radius is 8 centimeters. So if I redraw my triangle, okay, I have a right angle here, 8 here, 5 here, and x. So using my Pythagorean theorem, I get x squared plus 5 squared equals 64, or equals 8 squared. Getting ahead of myself. And we get x squared plus 25 equals 64. Okay, subtract 25 from both sides. Okay, and we get x squared is equal to 39. So x is equal to the square root of 39. And we get approximately equal to 6.24. Okay, since we're dealing with measurements, that is centimeters. Okay, let's look at another example here. Well, first, our theorem here is a tangent to a circle. So a tangent is a line that goes through and just touches once the edge of the circle. Okay, so a tangent to a circle and a radius at that point of contact meet at a right angle. So that tangent line makes a right angle with our radius. Okay, so let's look at an example how we can use that to solve a problem. Okay, tangent of length 10 centimeters is drawn to a circle with a radius of 7. Okay, how far is the center of the circle to the end point? Center of the circle to the end point, that's our unknown. So our right triangle is here, right angle here at the tangent. This is 7. This is our unknown D, and this is 10. So using our Pythagorean theorem, we see that 7 squared plus 10 squared equals d squared. So we get 49 plus 100 equals d squared. So 149 is equal to d squared. So d must be equal to the square root of 149. We use a calculator to approximate that. And we get that it's approximately equal to 12.21 centimeters. Okay, that concludes our notes for tonight. Please highlight any questions you might have and bring them to class tomorrow.